Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 12th. Mathematics class 12th, we have been seeing inverse trigonometric functions. We have seen exercise 2.1 and now is the turn of exercise 2.2. We'll see all the questions of exercise 2.2 one by one. There are a lot of questions in exercise 2.2. It is a very important exercise based on the properties of inverse trigonometric functions. Yes, you should be aware of all the properties, interconversions, and not only that, interconversions in terms of multiple and submultiple angles as well. All of those things are important and those things will be discussed with you over here. Maybe before this you should have studied the domain, range, graph and all related to exercise 2.1 as well. Revise those things properly and then we'll see the questions over here. Let's take a look at this first question. What does the question say? Prove the following: 3 times sine inverse x is equal to sine inverse of 3x minus 4x cube. Now what's the important thing in this? Let's take a look at this. The important thing in this question is that this expression over here is something similar to this expression over here is what we know. What do we know? We know that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Okay, this is something that we are already aware of. This is a formula of sine 3 theta, yes. Okay, this is something which we studied in class 11th, yes. Okay, so will this formula be useful over here? Yes, you observe that 3 times sine theta minus 4 times sine cube theta. 3 times something minus 4 times that something cubed. 3 times something minus 4 times that something cubed, or 3x minus 4x cubed, wherein you can observe that this x can be substituted as sine theta. This x can be substituted as sine theta, right? Let's observe. X can be substituted as sine theta, or you can observe this also, x equals sine theta, or instead of that can you say that sine inverse x is equal to theta. Can you observe this, right? And this is the substitution that we are looking at. This is the substitution that we have to make on the basis of this analysis up till now. So the first thing that I do is let sine inverse x equals theta, where one important thing is already known. What is that? This is the interval in which x lies. This is the interval in which x lies. Let's write that interval as well, where minus 1 by 2 is less than equal to x is less than equal to 1 by 2. This is given to me. I am substituting this sine inverse x as theta, where x is already in the interval, already given lying in the interval minus 1 by 2 to 1 by 2. Benefit of this, let's observe. Once this is known, then can you also guess the values of theta from here? Yes. Where minus 1 by 2 is less than equal to x is less than equal to 1 by 2, what can you comment about the values of sine inverse x? This gives me sine inverse x is less than equal to and greater than equal to. Sine inverse x is also increasing, right? Is an increasing function, therefore sine inverse 1 by 2 will come over here. Sine inverse minus 1 by 2 will come over here. What is the value of sine inverse 1 by 2? Sine inverse 1 by 2 is simply pi by 6. That's the value of sine inverse pi by 1 by 2. And what is sine inverse minus 1 by 2? This is minus pi by 6 over here. Okay. So now we are aware of the values of theta as well. Okay. Therefore, theta is less than equal to pi by 6, greater than equal to minus pi by 6. Now, why are we doing all of these things? There's an important reason for that. But the reason I'll explain after a few steps. You will realize that why are we doing this after a few steps, but this is important. We started with the values of x that is given to us and we found the values of theta, that is from minus pi by 6 to pi by 6. This step is important. This step could have been done later. No, this step has to be done right now. And once you have substituted sine inverse x equal to theta, where theta is from this to this interval, then now we begin with this complicated expression over here. Let's begin with this. By the way, this gives me x equals sine theta. This gives me x equals sine theta. Yes. Now begin with this complicated expression. Sine inverse 3x minus 4x cube is equal to what? This is equal to, let's write it over here. This is equal to sine inverse 3 sine theta minus 4 sine cube theta. Because we've used a substitution over here in terms of theta, x is simply sine theta. Let's replace this x by sine theta. Benefit of this is this can be written as sine inverse sine 3 theta. Using that we can write it in this manner, right? Is that okay? Yes, that's pretty simple. Is there any issue in this? No, there is no issue up till now. What else? Now, remember one more thing from the properties of IDF. What should we remember? We should remember that sine inverse sine x, that is t inverse of t. We have learned how to define t inverse of t, and this is simply equal to x, but there is a condition. What's the condition? That x must be less than equal to pi by 2 and greater than equal to minus pi by 2. Only if x lies in this interval, this is the output. If x will not lie in this interval, then some of you may recall some things which you have studied while preparing for the JEE or somewhere else maybe, that this particular expression, this sine inverse sine x, has a periodic graph, and different definitions can be found in different intervals. I'm just giving a glimpse of that kind of a graph, sine inverse sine x. For minus pi by 2 to pi by 2, this is the graph. Beyond pi by 2, the graph goes like this, up till 3 pi by 2. Then the graph goes like this, up till 5 pi by 2. What's the intercept over here? The intercept, can you observe that this here is 0, this is pi, this is 2 pi, and so on and so forth. This here will be minus pi. What about this topmost point? This topmost point will be at minus 3 pi by 2. This is the graph, and from here you can note the definitions in different intervals. But do we actually require all of those definitions over here? The NCERT people have made your life very easy in this case. How have they made your life very easy? Please observe that sine inverse sine 3 theta, and where does 3 theta lie? If you observe carefully, 3 theta will lie in the interval minus pi by 2 to pi by 2. Sine inverse sine x, where x lies from minus pi by 2 to pi by 2. Yes, the output will be simply x. And how have they ensured that you only focus on that definition? Is by giving you the values of x. From x, we got the values of theta. Yes, you said that you will express the use of this calculation. Yes, I have expressed the use of this calculation over here. Since theta belongs to minus pi by 6 to pi by 6, we can observe that 3 theta is between minus pi by 2 to pi by 2. Had 3 theta lied in another interval, let us say pi by 2 to 3 pi by 2, we would have used this definition. Okay, what is this definition over here? This definition over here. Let's first write this definition. This definition is pretty simple. This is sine inverse sine x. If the graph is of y is equal to sine inverse sine x, then this line is actually y equals to x. It's pretty simple. What about the other line, the next line over here? This line over here is y equals pi minus x. This equation of a straight line is not a difficult thing, right? Equation of straight line is pretty simple. This is y is equal to pi minus x. Similarly, that here has another definition. This here has another definition. Right. Let's come back to this question and complete this question now. Sine inverse sine 3 theta for 3 theta lies in this interval will be equal to simply 3 theta. But did we start with theta? Were we given theta in the question? No. Can we leave the answer in terms of theta? No. We will have to leave the answer in terms of x. Now what is theta equal to? Theta is equal to sine inverse x. This is 3 sine inverse x. So we began with this and we reached this. Yes. That's a complete proof. Let me reiterate the important concepts and the important points which I have written on the right hand side for you. The proof is only this much. But a lot of things are involved over here, beginning from this formula to this kind of a substitution. We were interested in this kind of a substitution. So what do we actually substitute is this. Who can we not substitute this directly? If you substitute this directly, you will not be able to note this, this and this further, on the basis of which you get this. for your board examination, many times, this analysis over here is assumed that, okay, you know it, right? This is the complete solution, what you call the complete logical explanation of why is this happening in this manner and why are we not using pi minus 3 theta or 3 theta minus pi over here, right? Why are we not using pi minus 3 theta or minus pi minus 3 theta over here? Although this particular expression will be equal to various definitions in terms of 3 sin inverse x in general. Ooh, will it be equal to various other definitions as well? Yes, it will be equal to various other definitions as well, and I can explain those things as well to you. If you are interested in going further beyond this, then you can continue this question further. Otherwise, you can move on to the next question. By the way, what are we trying to deal with over here is, I want to simplify this expression, sin inverse 3x minus 4x cube. Now the initial steps will be same, this and this will be same, but herein the value of x will not be from minus 1 by 2 to 1 by 2, that has been given to us. We'll consider x from minus 1 to 1, okay. Sin inverse x will lie from minus pi by 2 to pi by 2, and this will lie from minus 3 pi by 2 to 3 pi by 2, yes. This will remain same, and at this stage you'll realize that 3 theta lies from minus 3 pi by 2 to 3 pi by 2. So in this interval, remember the graph, yes, minus 3 pi by 2, pi by 2, pi by 2, sorry, this is minus pi by 2 and this is 3 pi by 2, will actually get 3 different definitions, yes. One definition is this, the other is this, and the third is this. What are these definitions? This is y equals x, this is y equals pi minus x, this is y equals minus pi minus x. So major analysis is same except for this calculation over here, which will make a difference over here. This remains same. What happens to sin inverse sin 3 theta? The value of sin inverse sin 3 theta will be equal to minus pi minus 3 theta, that is minus pi minus x. This can be equal to 3 theta, or this can be equal to pi minus 3 theta. Pi minus x will imply pi minus 3 theta when 3 theta, that is this 3 theta lies in this interval minus pi by 2 to pi by 2. Before this, in this interval, minus 3 pi by 2 is less than equal to 3 theta is less than pi by 2, you get this definition. In the interval after this, you get another definition. What's that? Pi by 2 is less than 3 theta is less than equal to 3 pi by 2. Okay. So different definitions in different intervals. And now you can observe one more thing, that these people are pretty smart. They've chosen the easiest one for you. They've chosen the easiest one for you over here. It's okay. They've chosen the easiest one, but we can handle difficult ones also with this much information. Yes, with this one information, you can handle the extra ones as well, right? If you are feeling adventurous, more adventurous than this, and you want to go a step further, then you can also think of drawing the graph of this. Ooh, the graph of this, yes. Based on definitions in different definitions and different intervals, you can draw the graph, and I'll give you the answer for verification. Verification, yes, so that you can verify your answer. This and this, this and this. This is the shape of the graph. This here is minus 1, this here is plus 1. So the values of x will lie from minus 1 to 1. And that is the actual domain of this. Domain of sin inverse 3x minus 4x cube will be from minus 1 to 1. Definition will change at minus 1 by 2 and 1 by 2. Those are the points at which definition changes. Right. And yes, obviously, NCERT people have chosen the easiest portion, that is minus 1 by 2 to 1 by 2 for us. They've asked that question. But we can handle the difficult ones. And yes, you can try and draw that graph as well. If you're going ahead for JEE examinations and all, you should be able to draw that, right? So with all of this in our mind, The solution of this is clear. Let's move on to the next question. Let's solve this question next. 3 cos inverse x is equal to cos inverse 4x cube minus 3x. And here also an interesting thing has been given, that is the values of x. Let's try and solve this one. We have studied a few important things in the previous question and seen some extra results related to this. But here now let us focus on what the NCERT people want. Observe carefully that 4 cos cube theta minus 3 cos theta is equal to cos 3 theta. This is the formula that you should be aware of. This is something which you should be aware of already. If you're not aware of this, please let's understand this formula and memorize this formula carefully. 4 cos cube theta minus 3 cos theta is equal to cos 3 theta, and if you're not aware of this, you would not be aware of a lot other formulae as well. Let me write a few more formulae for you. 3 sin theta minus 4 sin cube theta is something which you would be aware of by now. This is sin 3 theta. Similarly, tan 3 theta is something that you should be aware of, tan 3 theta, or should I write it in the similar fashion? 3 tan theta minus tan cube theta over 1 minus 3 tan square theta is actually tan 3 theta. Now these are results related to 3 theta. What about results related to 2 theta? You can have that as well. 2 sin theta cos theta is equal to sin 2 theta. Or you can write this cos theta as under root of 1 minus sin square theta as well. So you in future you may encounter something 2x times 1 minus x square in the under root, right? So you know what kind of a substitution we want to use over there, right? What else? Cos 2 theta, yes. So 2 cos square theta minus 1 is equal to cos 2 theta. What about the other results? No, you can substitute cos theta and 2x, in case of 2x square minus 1, you'll use this. Right. What else? For tan x, yes, 2 tan theta over 1 minus tan square theta is equal to tan 2 theta. If you remember these results carefully, that is the values of cos theta, formula for tan 2 theta, sin 2 theta, tan 3 theta, sin 3 theta, cos 3 theta, you'll be able to solve questions based on those formulae. Let's take a look at this one. The important thing that we observe is that x has to be replaced by cos theta, or we have to substitute cos inverse x as theta. So let's use that substitution. Let cos inverse x equals theta, which gives me x equals cos theta. But one important thing has to be done over here only. What is that important thing? On the basis of this, since it is given that x belongs to this, let's find the values of theta first. Let's find the values of theta first. This says that x is greater than equal to 1 by 2, less than equal to 1 as given. Right, this is given to us. And since x lies in this interval, implies cos inverse x. Now if you take the cos inverse, you know that cos inverse is a decreasing function. Yes. Since it is a decreasing function, the signs of inequality will reverse. So what you'll get is cos inverse 1 over there. Now if x is less than equal to 1, cos inverse x will be greater than equal to 0. The value of cos inverse 1, that is 0. And yes, less than equal to cos inverse 1 by 2. What's the value of cos inverse 1 by 2? Remember that this is pi by 3. Sign will reverse. This is one important thing. Since cos inverse x is a decreasing function. Since cos inverse x is a decreasing, remember the graph of cos inverse x? This is what the graph of cos inverse x looks like. Right? This is as we move along x towards the right, the values of y decrease. So this is a decreasing function, right? For half to 1, if this point is 1 by 2, you observe that this is the graph. And the values of cos inverse x will be from 0 to this point. What is that? Pi by 3 over there. Right? Okay. And from here you can say that theta is greater than equal to 0 is less than equal to pi by 3. Okay. Now let us begin with the RHS. In the RHS you have cos inverse 4x cube minus 3x, which can further be written as cos inverse on the basis of this x over here. 4 cos cube theta minus 3 cos theta. And this will further be written as cos inverse cos 3 theta. Now what happens in case of this? Cos inverse cos x. Let's recall the definitions of cos inverse cos x will be equal to x. Cos inverse cos x will be equal to x when x lies in the range of this. Right? That is from 0 to pi. Okay. Now where does 3 theta lie? Can you observe that? 3 theta will be greater than equal to, this is 0 over here, mind you. Oh, 3 theta lies in the interval 0 comma pi. Yes. So cos inverse cos x is equal to x if x lies in the interval 0 comma pi. Therefore cos inverse cos 3 theta will be simply equal to 3 theta, since 3 theta is greater than equal to 0 is less than equal to pi. That's the simple definition of this. Okay. And what is theta? Theta is simply cos inverse x, which is equal to the LHS, hence proved. Now this is the result when x lies in this interval. What happens if x does not lie in this interval? Is this the actual domain of this? Right now we are only asked to find this in terms of this, right? In case you consider all other values of x, you will get more definitions, more results. If you want to go further, beyond this, although we have solved the question completely, but if you want to go beyond this, let's take a look at one more thing. What is that? Cos inverse 4x cube minus 3x will be equal to cos inverse cos 3 theta, as we have solved over here. Okay. And what will 3 theta be equal to? This will be equal to various things depending upon the values of 3 theta. Now in this interval you are given that x belongs to 1 by 2 comma 1. If not, then in general x will be from minus 1 to 1. In general x will be from minus 1 to 1. Okay. And then cos inverse x will be from 0 to pi. Cos inverse minus 1 is pi, right? And cos inverse x implies theta. Okay. What next? 3 theta will be greater than equal to 0, less than equal to 3 pi. Okay. So we'll need definitions from 0 to pi. It is very simple. From 0 to pi, it is very simple that you will have 3 theta. From 0 is less than equal to 3 theta is less than equal to pi. After pi, what happens to the values of 3 theta up to 2 pi? And what after that interval? You'll have to look at the other definitions of this cos inverse cos theta. Let's try to draw the graph of cos inverse cos x. The graph of cos inverse cos x looks like this. Okay, what are the points over here? This point is pi, this point is 2 pi, 3 pi, 4 pi. These are the various definitions: pi, 2 pi, 3 pi, 4 pi and all. Right. And what else? This definition is y is equal to x. This is y is equal to x minus 2 pi. This is y is equal to 2 pi minus x and all. Sorry, just a minute. This is 2 pi minus x. Let's interchange this as 2 pi minus x, and this is x minus 2 pi. So you have various definitions, and on the basis of that, various results. 2 pi minus x would imply 2 pi minus 3 theta. 3 theta minus 2 pi. This is what you get. These are 3 different definitions. But here in this question, we are given thus the easiest one. That's the easiest one, right? Therefore, they've chosen this interval very wisely. If you remember in the previous question, they've given an interval from minus 1 by 2 to 1 by 2. There was something special about that, right? That was the easiest interval. Here also they've chosen 1 by 2 to 1, which is, it's again the easiest interval. And yes, only after analyzing this, we realized that, okay, this conversion from here to here became very simple. Otherwise, it can be complicated as well. It can be pretty complicated as well. Okay, so that's the complete discussion. All of this we have discussed over here is extra, but for this question, from the point of view of NCERT, this much is sufficient. This much is sufficient, right? That's the solution of this question over here. Let's discuss this question next. Tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. What to do for this question? So you should remember a formula related to tan inverse. This tan inverse x plus tan inverse y is equal to single tan inverse of x plus y over 1 minus xy. But then not only this, you should remember a special condition related to xy. The product xy is less than 1. The product xy is less than 1. X should be greater than 0. Y should be greater than 0. If x is greater than 0, y greater than 0 and the product xy is less than 1, then only this formula holds. Otherwise, you will have a different version, a different formula. Okay. So, you should not only remember this formula, you should also remember the conditions related to the formula. That's very important. And once you remember the conditions, then it is very simple to apply the concepts. This result over here. You observe that, okay, in the LHS, what you have is tan inverse 2 by 11 plus tan inverse 7 by 24. Okay. And 2 by 11 times 7 by 24 is actually 7 by 11 times 12. What is that? 132? Which is less than 1. Okay. Which is less than 1. Therefore, this becomes equal to tan inverse of x plus y over 1 minus xy. This. Since we remember that version, right? Reason behind this is using 1. Let's call this 1. Using 1. What next? Let's simplify this and get the answer. What are we supposed to get? We're supposed to get that single tan inverse 1 by 2. Let's see, what does this simplify into? This is tan inverse 2 by 11 plus 7 by 24. Can we take LCM? 11 into 24? Yes, this will become 48 plus 77 over 11 times 24, 11 times 24, denominators will get cancelled in both numerator and denominator. 11 times 24 would be 240 and 264 minus 7 to 14. This is what you will get, suppose, right? This is what you are getting. Please check that result. 11 times 24 is this 264 and 7 times 2 is 14. 2 times 24 is 48, 11 times 7 is 77 and this is what you get. Let us simplify this further. This will become tan inverse of 48 plus 77. What is that? 8, 7, 15, 1, 125 over, this is 250. Okay. Numbers are pretty big, but yes, they will get cancelled. This is tan inverse 1 by 2 and this is the RHS. This is the RHS, hence proved. With the help of this result over here. With the help of this result. X greater than 0, y greater than 0 and xy less than 1. If this is true, then this expression tan inverse x plus tan inverse y is equal to tan inverse of x plus y over 1 minus xy. Let me get aside so that you can take a look at this complete solution over here. And that is all for this question. Let's solve this question next. What does the question say? 2 tan inverse 1 by 2 plus tan inverse 1 by 7. Okay, there are a lot of tan inverse in the left hand side, but there is a single tan inverse on the right hand side. So what are we supposed to do over here? Oh, what next? We'll have to combine these tan inverse to simplify the result, right? Let's do it. Let's do it. Now the result that we are aware of is that tan inverse x plus tan inverse y is equal to tan inverse x plus y over 1 minus xy, where x comma y greater than 0 and x into y is less than 1. This is one important result. You remember one more result based on this when x and y are equal. If x and y is equal, that is y equals x, we have another result, right? What's that? This becomes tan inverse x plus tan inverse x, which is 2 tan inverse x, which will be equal to tan inverse of 2x over 1 minus x squared. This is another result which is given in the NCERT itself, right? What is important over here is that, mind you, the product of xy, that is x square, is less than 1. Less than 1, and you can also say that x is greater than 0. This is what you can say, right? X greater than 0. Since there is only an x involved, there is x greater than 0 and x square is less than 1. This is what you have. This is the next result, right? Is that okay? That's pretty much okay. What happens in case of x less than 0? Mind you, for x less than 0, what you can simply do is you can take a minus out from here itself. You can use tan inverse minus x equals tan inverse x. Okay. And what will happen in this right hand side? The right hand side, in the right hand side also similar thing will happen, that is minus will come out over here. Oh, so you can actually cancel out those minuses. So this particular result may be true for x less than, is also true for x less than 0. This is also true for x less than 0. But remember this along with this. Mind you, this result is true for x less than 0 as well, wherein x square should be less than 1. This is still important. This is still important, but x less than 0 can also work over here. So if you are remembering this result, then a similar result can be remembered in this manner, or you can skip that x greater than 0 over here, since x less than 0 will not make much of a difference in the final result. So therefore, the NCERT people only talk about this one. They don't talk about this. Right. But for memorizing on the basis of this, you can will not make a difference, right? I said minus and minus will come out and the result would be exactly same. So what next? Let's try to begin this question now. We have 2 tan inverse x, that is 2 tan inverse 1 by 2 over there. Let's begin with the LHS. 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is what we have. And this 2 tan inverse 1 by 2 can be written as tan inverse 2 times 1 by 2, that is 2x over 1 minus x square, that is 1 by 2 whole square. Since 1 by 2 is greater than 0 and 1 by 2 square is 1 by 4, which is less than 1, this. Right. Since this is true, therefore this result holds. Therefore we have applied this tan inverse 2x over 1 minus x square. What happens to this tan inverse 1 by 7? This will remain as it is. This will remain as it is. We have used that result. This will convert to tan inverse of, this is 1 over 1 minus 1 by 4, which is 3 by 4. This will become 4 by 3 in the bracket plus tan inverse 1 by 7. Observe this carefully. 1 minus 1 by 4 is actually 3 by 4. Reciprocal would be 4 by 3. And after reaching this stage, you see this is positive, this is positive. What is the product of these numbers? 4 by 3 times 1 by 7 is 4 by 21. 4 by 21, is it less than 1? Yes, it is less than 1. Can I apply that result? Yes, I can apply that result. This will imply tan inverse x plus y is tan inverse x plus tan inverse y is tan inverse x plus y over 1 minus xy. This is what you get. Let's simplify it further. That's the formula application is done and only calculations remain after this. What is this? 28 plus 3 over 21 in the denominators will get cancelled. This is 21 minus 4. What is this? This is tan inverse of 31 over 17, which is my RHS, and yes, that's the complete proof of this question over here. That's the complete solution using these two results, and that's all for this question. Let's see the next question next. Write the following functions in the simplest form. What are we supposed to do in this? We're given this function which looks pretty complicated. Yes, this looks pretty complicated. You have a tan inverse, which is in itself a difficult thing. And then you have the under root of x square, 1 plus x square minus 1 upon x, a complicated expression. Can this be simplified into something else? Let's see. Okay. So what are the hints that we have in the question itself? X is not equal to 0. Okay. So there are no limits on x related to minus 1 and 1. Okay. So possible substitutions could have been x equals sine theta, cos theta, tan theta. And if you observe this x is not equal to 0, it implies that maybe sine theta and cos theta will not work over here, tan theta works over here, since x is lying in an interval beyond minus 1 and 1 as well. Okay, so x equals tan theta may work, right? And you can realize that from by looking at this as well. This is 1 plus tan square theta, which is sec square theta, and can be simplified in terms of the square root. Had there been 1 minus x square, you would have thought of sin theta and cos theta. But since this is 1 plus x square, we'll have to think in terms of tan theta, right? So the substitution that we are going to make is x equals tan theta, or let tan inverse x equals tan theta, tan inverse x equals theta, which actually give me x equals tan theta, right? This is what you get. Okay. Now what about this x? It is given that x is not equal to 0. That's the domain of this. It is given that x is not equal to 0. Therefore, theta will not be 0. That's a simple thing. Yes. Anything else? No, nothing else. Theta lies in some interval. Minus pi by 2 is less than x is less than, sorry, minus pi by 2 is less than theta is less than pi by 2, except for theta is not equal to 0. With the help of this, you can note that tan inverse x, the output of tan inverse x is from minus pi by 2 to pi by 2, open intervals, right? Therefore, theta lies in this interval. But theta is not equal to 0 based on this. That's okay. That's okay. So once you have noted this, therefore, the expression tan inverse under root of 1 plus x square minus 1 whole divided by x becomes equal to what? This expression becomes equal to what? Now comes the answer solution. Tan inverse of under root of 1 plus x square will become under root of 1 plus tan square theta minus 1 whole divided by tan theta. What else? 1 plus tan square theta, this will further simplify to 1 plus tan square theta is sec square theta, under root will be sec theta minus 1 over tan theta. Okay, this looks complicated. Can this be converted into tan inverse of tan something? Can this be converted in terms of tan? That's the question. Tan of some angle, yes. Let's try to do that. Inverse of sec theta is actually 1 upon cos theta. Let's try to simplify by multiplying cos theta, since this also has a cos theta in the denominator. This is 1 minus cos theta over sin theta. What I've done is multiplied numerator and denominator by cos theta. So this becomes cos theta times sec theta, which is 1, minus cos theta times tan theta, which is sin theta. What else? Now, I can convert 1 minus cos theta and sin theta in terms of half angles. Yes, benefit of converting into half angles would be this. 1 minus cos theta can be written as 2 sin square theta by 2, and this can be written as 2 sin theta by 2 cos theta by 2. Okay. So therefore, this is tan inverse 2 gets cancelled, sin theta by 2 gets cancelled, and what you get is sin theta by 2 upon cos theta by 2, which is actually tan theta by 2. And what happens in this case? Tan inverse tan theta by 2. If theta lies in this interval, theta by 2 will lie in a more restricted interval, that is from pi by 4 to minus pi by 4 to pi by 4, and in that interval the definition of tan inverse tan theta, tan inverse tan x will be x only, that is theta by 2. What is theta? Theta is something that we started with. Theta is tan inverse x. So this is 1 by 2 times tan inverse x. That's the simplified version of that. This is the answer for that question over here. That's the simplified version of this expression. That's the complete solution. Let me get a side so that you can take a look at this. With this, we come to the conclusion of this question. Let's try and solve this question next. What does the question say? Tan inverse 1 upon under root of x square minus 1, where mod x is greater than 1. Okay. Since mod x is greater than 1, you would realize that the substitutions x equals sin theta, cos theta will not work over here. Sin theta, cos theta are not greater than 1, they are less than 1. The mod x greater than 1 has a hint of maybe applying substitution related to sec theta and cosec theta. And also we get a similar kind of a hint from here as well. X square is, if x is sec theta, then this becomes sec square theta minus 1. Yes. Which can be further simplified to give us something very easy. Right. Why not do that? Let's try and solve this one. Yes. So the substitution that will make is x equals sec theta or sec inverse x equals theta. Which gives me x equals sec theta. Condition that we are given is mod x greater than 1. Okay. So mod x greater than 1 would imply theta lies in which interval? This will imply that mod x greater than 1 would imply x greater than 1 or x less than minus 1. Okay. The values of sec theta lie in the interval 0 comma pi by 2 union pi by 2 comma pi. So theta belongs to 0 comma pi by 2. Pi by 2 is open for sec theta, and moreover, since it is greater than 1 not equal to 1, so 0 will also be open, union pi by 2 comma pi. This is the interval in which theta lies. Okay. Therefore, tan inverse of, let's take a look at 1 over under root of x square minus 1. What is this equal to? This is tan inverse of, let's substitute the value of x. What is x? X is sec theta. This becomes sec square theta minus 1 and its under root. Tan inverse 1 over, this is what? What is this? Sec square theta minus 1 is tan square theta, under root of tan square theta will be tan theta. Okay, so this becomes tan inverse of 1 upon tan theta or tan inverse of cot theta. Pretty interesting. What will happen to this tan inverse of cot theta? If you observe carefully, tan inverse of converting this in terms of tan, that's also okay, that can be done. This cot theta can be written as tan of pi by 2 minus theta. So we will get tan inverse of tan pi by 2 minus theta, and pi by 2 minus theta, pi by 2 minus pi will lie in the interval minus pi by 2 to pi by 2. Yes, this will be the interval minus pi by 2 to pi by 2, wherein we can define very easily. So from here we can move in one direction, that is tan inverse of tan pi by 2 minus theta using complementary angles, and this will further be equal to pi by 2 minus theta, which is pi by 2 minus theta. What is theta? Theta is sec inverse x. Or you could have moved in another direction. What is that? You remember properties of ITF as well related to complementary angles. Tan inverse of cot theta, tan inverse of something is also equal to cot inverse, in terms of cot inverse is also equal to minus cot inverse of that something. Where theta lies in this interval 0 to pi, yes, that's the output in which the result of cot inverse should lie. So this is pi by 2 minus theta only. Cot inverse cot theta will be theta, and yes, this is pi by 2 minus sec inverse x. No, we are getting the same thing. We should be getting the same thing, right? Something which is there. So in this I have applied results of ITF related to complementary angles. Here I have applied results of complementary angles related to trigonometry directly. Okay, is that all? So that's the complete solution for this question. What's the benefit? Remember, what's the benefit of writing this whole expression as this simplified expression? Pi by 2 minus sec inverse x is further analysis, further drawing the graph, further modification, maybe differentiation as well. If all of those things are involved, then this function is relatively easier to tackle rather than this form of the same function, right? That's the complete solution and analysis of this question over here. Let's discuss this question next. Tan inverse of under root 1 minus cos x over 1 plus cos x, where x lies in the interval 0 comma pi. Let's see, how do we approach this one? So the expression that I am given, how can you simplify that expression? Please observe, this is 1 minus cos x, which is pretty simple. 1 plus cos x is again very simple. This and this can be converted, this ratio can be converted in terms of tan theta by 2, tan x by 2, right? There's a formula, 1 minus cos 2 theta over 1 plus cos 2 theta is tan square theta. So this expression is equal to tan inverse of under root this. 1 minus cos 2 theta, 1 plus cos 2 theta will be tan square theta, that is half of this angle, which is x by 2. Oh, is it? Yes. And once I have reached this, there is no need to substitute anything. I can simplify it as this, and under root of tan square this, what will this become? This will be tan x by 2. And if you observe carefully, tan inverse tan of x by 2 will lie in the interval 0 comma pi by 2, and in that interval tan inverse tan x is simply x. So tan inverse tan x by 2 will be simply x by 2. Oh. So this expression simplifies into this. Yes. Since x by 2 is between 0 and pi by 2. That's the answer. That's the simplest form of this question over here. Very simple analysis. There is no need to substitute anything. We are simply able to solve this directly. Yes, that's all. Let's try and solve this one next. Which are, write the following functions in the simplest form. Let's try to simplify this. Tan inverse is there in the outside. Let's try to convert this in terms of tan of something. Okay, can we do that? Yes, maybe. But for that, I want you to recall one formula, one form. What is tan of pi by 4 minus x? Well, this is something which you may have studied in class 11th. Tan of pi by 4 minus x is tan pi by 4 minus tan x over 1 plus tan pi by 4 tan x. Tan pi by 4 is 1 minus tan x over 1 plus tan pi by 4 into tan x. This is what you get, right? Right? Yes. What's the benefit of using that? The benefit will be clear over here, right? This tan inverse of cos x minus sin x over cos x plus sin x can be converted into that form in the RHS very easily. By dividing numerator and denominator by cos x. Cos x upon cos x is 1 minus sin x upon cos x is tan x over, this is 1 plus tan x, and now I can write it as tan inverse. 1 is tan pi by 4. Do you observe? 1 can be written as tan pi by 4 minus tan x is already there. This is 1 plus something tan pi by 4 times tan x. What next? Yes, this has been simplified further. This is tan inverse tan of pi by 4 minus x. What about the values of this pi by 4 minus x? The interval, mind you, is important. I've been saying this over and over again. The interval, the given interval is very important because x is greater than minus pi by 4 is less than 3 pi by 4 implies that minus x will be greater than minus 3 pi by 4 less than pi by 4. Multiply with the minus. Then you add a pi by 4. Then you add a pi by 4. You add a pi by 4 over here. This becomes minus pi by 2. Pi by 4 plus pi by 4 will become pi by 2. So pi by 4 minus x is actually lying in the interval minus pi by 2 to pi by 2. Tan inverse tan x will be equal to x if x lies in the interval minus pi by 2 to pi by 2. Tan inverse tan something, where something lies in the interval, this will be equal to that something. What is that? Equal to pi by 4 minus x. One more important observation. From here I can directly go to pi by 4 minus x. Observe carefully. The sign of inequality will change. Pi by 4 minus 3 pi by 4. What will that be? Pi by 4 minus x is here. Pi by 4 minus 3 pi by 4 will be minus pi by 2. And since you are multiplying x to the minus, the sign of inequality will change. Pi by 4 minus of minus pi by 4. Pi by 4 plus pi by 4, which is pi by 2. And sign of inequality will change. This is what you can do. Instead of going stepwise in this manner, you can directly go this manner if you are comfortable with that. If you're not comfortable, you can simplify this. Right. So this is the simplest form of the original question given. This is the interval. That's the final solution for this question. Solve? Yes, that is all in this question. Let's try and solve this question next. Tan inverse of x upon under root of a square minus x square. So seeing that a square minus x square, I realize that this may be converted in the form of 1 minus sine square theta or 1 minus cos square theta. And I get a similar feeling from here. Mod x is less than a. Ooh. Mod x is less than 1 implies we can substitute x as sine theta. But mod x less than a would imply that I have to substitute a as x as a sine theta maybe. Yes, that's what you'll be thinking. So here we need to make a substitution. Let x equals a sine theta. Now this particular thing will be okay. Yes. And what will this simplify into? Therefore, tan inverse of x upon under root of a square minus x square further simplifies into what? This becomes tan inverse of x. What is x? X is a sine theta over a square minus x square in the under root, which is a square minus x square, is a square minus a square sine square theta, and then there's an under root over here. There's an under root over here, yes. So let's take a square common from here. 1 minus sine square theta will be cos square theta. This becomes a square times cos square theta. Okay, so this becomes tan inverse times a sine theta over a square times cos square theta. Under root would imply a times cos theta can be taken over here, right? This is what you get. Once you're okay with this, a's get cancelled, sine theta upon cos theta becomes tan theta. This is tan inverse of tan theta. And where does the value of theta lie? Depending on that, we'll be able to define tan inverse tan theta as theta or something else. Although the probability of this being something else is very less, since this is a question from the NCERT. So the output will be actually theta only, but let's check the values of theta first. We began with this, or we can say that sine inverse x by a is equal to theta. This is what we began with. X by a, sine inverse is this theta, right? Depending upon the values of x, mod x is less than a, we say that mod x is less than, mod x upon a is less than 1. X upon a, this is less than 1. Therefore, x upon a is less than 1 greater than minus 1. Using inequalities of mod, right? On the basis of this, I say that sine inverse x by a is less than sine inverse 1, which is pi by 2 greater than minus pi by 2. And this is the value of theta. Theta is between minus pi by 2 pi by 2. Therefore, tan inverse tan theta is simply theta, which is okay. Now, what is theta? Theta is sine inverse x by a. And yes, this is my simplest form of this complicated expression. Sine inverse x by a is the simplest form of this expression. That's the answer for this question. Let's solve this question next. A very interesting version of a pretty complicated question in itself. The expression that I would require, let me recall that expression. Tan 3 theta is equal to what? You remember the formula of tan 3 theta in terms of tan theta? Let's remember that. This is 3 tan theta minus tan cube theta over 1 minus 3 tan square theta. This is required, right? Where did you get that idea from? I got that idea from using this 3x x cube, 3x cube, right? Focus on the x, not on the a. A is a constant. We can always multiply, divide by a and simplify that expression into something else, right? Convert that expression as well. You can observe carefully that x is less than this, greater than this. X lies in some particular interval, yes. A is greater than 0 and you have to convert this in terms of tan inverse. So we'll require that. Okay. What kind of a substitution are we looking at? We are looking at a substitution where x upon a is tan theta. Where x upon a is tan theta, or let x equals a tan theta. Let x equals a tan theta, which implies theta is equal to tan inverse x over a. It is also given that minus a by square root of 3 is less than x is less than a by square root of 3. From here I can get the range of theta. Which is important for finally writing the final expression. This will give me x upon a. Let's divide with a. A is positive, so sign of inequality will not be affected. A is positive, so sign of inequality will not be affected. X upon a. Now take the tan inverse. X upon a, which is actually theta, is less than tan inverse of 1 by root 3. Which will, what is that? This is pi by 6 and this is minus pi by 6, right? Those are the values. Okay. So these are the values of theta, yes. Now I can focus on further solution. What's that? Further solution? I can simplify that expression. Let's try to do that. Tan inverse of 3 a square x minus x power 3 over a power 3 minus 3a x square. Can we divide by a cube in the numerator and denominator? Yes. What will happen is tan inverse a cube. You divide by a cube over here. A square gets cancelled. A remains in the denominator. Minus x by a power 3. a cube upon a cube is 1 minus 3, a gets cancelled, x by a whole square. This is what you get. Is that okay? Yes, that's okay. 3 times x by a minus x by a whole cube upon 1 minus 3 times x by a whole square. And this looks pretty similar to that one where x by a can be further substituted as tan theta. We have done that, right? So this is tan inverse 3 tan theta minus tan cube theta over 1 minus 3 tan square theta, since x by a is tan theta. What is this equal to? This equals tan 3 theta. Yes. So this becomes tan inverse tan 3 theta. Now what happens next is, what is tan inverse tan x equal to? It is equal to x in the interval, when x lies in the interval minus pi by 2 to pi by 2. This is theta, right? What happens to 3 theta is less than pi by 2 greater than minus pi by 2. Yes. This is important. The condition was given in such a manner that you can simplify tan inverse tan 3 theta in terms of 3 theta, because 3 theta lies in the interval minus pi by 2 to pi by 2. Is that okay? Yes. This is 3 theta. Okay. And what was theta? Theta is tan inverse x by a. So this is 3 times tan inverse x by a. And that's the simplest form of this expression, as you can see. That's the final answer. Yes, that's the final answer for this question. Let me get a side so that you can take a look at the complete solution. This is the formula that we have used. Otherwise, the solution is this. Right? That's all. Let's try and solve this question next. What does the question say? Find the values of each of the following. Each of the following, there will be a few parts of this question. Let's see. Tan inverse 2 cos, 2 sin inverse 1 by 2. Okay. Looks pretty complicated, but if you realize that, don't read this question from the outside. Read this question from the inside. Okay. And go stepwise. Try to simplify each step one by one. This is equal to tan inverse of, I don't know what will happen to this cos, but I know that the value of sin inverse 1 by 2 is simply pi by 6. Yes. So this is 2 times pi by 6. Okay. So then this becomes tan inverse 2 cos pi by 3. Okay. And cos pi by 3 is something that I know. 2 is okay. Cos pi by 3 is root 1 by 2. Cos pi by 3 is 1 by 2. So this becomes tan inverse 1. Yes. And that further is equal to pi by 4. Yes. That's the answer for this question. Yes. Let's solve this question next. Find the value of cot of tan inverse a plus cot inverse a. What is tan inverse a plus cot inverse a? That is something that I know. Yes. Tan inverse of x plus cot inverse of x is always pi by 2 by the properties. That's something that we know from the properties. This is equal to pi by 2. So this becomes cot of pi by 2. Tan inverse a plus cot inverse a is simply pi by 2 using properties. Yes. And what is the value of cot pi by 2? This is simply 0. So that's all for this question. Yes, this is a simple solution of this question. Let's try to simplify this. Find the values of each of the following. Okay. This is one single question. It looks pretty big. Yes, it looks pretty big. You observe that you have a sin inverse 2x over 1 plus x square. Cos inverse 1 minus y square upon 1 plus y square. Now this is of some particular form. Yes. If you observe carefully, this is of the form 2 tan theta upon 1 plus tan square theta. This will become sin inverse sin 2 theta. Yes. This is 1 minus tan square theta 1 plus tan square theta, which will become cos inverse cos 2 theta. Yes. So the formulae that I'll require for simplifying this expression and finding the value are 2 tan theta over 1 plus tan square theta is equal to sin 2 theta. Not only that, I have another formula. What is that? 1 minus tan square theta over 1 plus tan square theta is equal to cos 2 theta. These are two formulae that I see over there and which will be useful for solving this question. What else? Is there anything else? Yes, I am given y greater than 0, mod x less than 1, and I am also given that the product of xy is less than 1. Okay, let's keep that in mind and try to solve this question further. Yes. Now sin inverse 2x upon 1 plus x square. We'll have to substitute x equals tan theta, or you can substitute tan inverse x equals theta. Let tan inverse x equals theta, which gives me x equals tan theta. What about cos inverse 1 minus y square? Y has to be substituted as tan theta. We substituted x equals tan theta, right? So we'll have to use a different variable over there. In case of y, we can use y equals tan phi maybe, yes. So tan inverse y will be substituted as phi, let us say. Okay, this gives me y equals tan phi, yes, yes. Therefore, this expression tan inverse of, what do you have over here? There's a half on the outside, there's a half outside there. Tan inverse half of this huge term, the bracket, that's sin inverse 2x over 1 plus x square plus cos inverse 1 minus y square over 1 plus y square. This is there, and this is what you have. This whole term will simplify into what? Let's see. This is tan inverse half of, observe, sin inverse 2 times tan theta. One plus tan square theta plus cos inverse. Instead of y, we have substituted tan phi. So let's write that. 1 minus tan square phi over 1 plus tan square phi. Since you have crossed this level, right? Next step will be to write this as tan inverse 1 by 2 is okay. Sin inverse, what is this? Sin inverse sin 2 theta. Plus cos inverse, this is again cos 2 theta. What about the values? Sorry, cos 2 phi. Mind you, this is cos 2 phi. Cos inverse cos 2 phi. Right, this is what you have. What next? What about the values after this? Sin inverse sin 2 theta can be written in terms of theta, right? Cos inverse cos 2 phi can be written in terms of phi, and the conditions that are given will be required, will be useful for that only. Sin inverse sin 2 theta, since mod x is less than 1, tan inverse this will be, theta lies in the interval minus pi by 4 to pi by 4. This will lie in the interval minus pi by 2 to pi by 2, and yes, this will be equal to 2 theta simply. What about cos inverse cos 2 phi? Now observe, this phi for y greater than 0, tan inverse y will lie in the interval 0 to pi by 2, yes. 2 phi will lie in the interval 0 to pi. Therefore, cos inverse cos 2 phi is simply 2 phi. The output should lie in the interval 0 to pi, that is being done over here, yes. What next? This becomes, let's multiply this half inside now. This becomes theta plus phi. Okay, this becomes tan inverse theta plus phi. Now what is theta? Observe, theta is tan inverse x. Yes, theta is tan inverse x, and we can substitute that very well. But if theta is tan inverse x, there should be tan over here. There should be a tan over here. There is a tan over here. Okay, so let's get rid of that. This original question had tan of this. Yes, we'll also take that. This is not tan inverse, this is tan of this, and this is actually tan of this. Let's write that carefully now. This is tan of theta plus phi, right? Noting the question properly. This is tan of theta plus phi, which is tan of, I can write tan of theta plus phi as tan of theta plus tan of phi over 1 minus tan theta times tan phi. Yes. And what will this be equal to? Tan theta is x, tan phi is y over 1 minus xy. That's your required value. That's your required value of this question, right? You started with tan instead of tan. It was not tan inverse, it was tan, okay, right? Right. And this is what you get after following these few steps. At this stage, we talked about the values, these conditions were given so that sin inverse sin 2 theta becomes exact 2 theta and cos inverse cos 2 phi becomes exact 2 phi. Had these conditions not been given, then we would have worried about a few more things in general. But then NCERT people only want this, therefore we have done this. Is that all? Yes, that's all in this question. Let's solve this question next. What does the question say? Find the values. Oh no, this line is not required over here. Question starts from here. Sine of sin inverse 1 by 5 plus cos inverse x equals 1. If this equals 1, then find the value of x. Okay. What are we supposed to do in this one? This is a question based on inverse trigonometric function equation. Right. So for solving equations, what are we supposed to do? Just solve the equation as you would solve a general trigonometric function, and without worrying about the conditions. What about the conditions? At the end, once you have solved the complete question, at the end, the value of x that you find, you check that value of x whether it is true or not for the given equation, right? So we have this equation sine of, first we'll solve this without worrying about anything. Sine inverse 1 by 5 plus cos inverse x is equal to 1. If sine of something is equal to 1, we imagine principal values and we solve, right? Then this particular expression sine inverse 1 by 5 plus cos inverse x will be equal to pi by 2. Since we are looking at principal values, this will be equal to pi by 2. Now from here I can observe that cos inverse x will be pi by 2 minus sine inverse 1 by 5. Okay. Now what is pi by 2 minus sine inverse something? This is cos inverse something, yes? We have a property. This will be cos inverse 1 by 5. Since sin inverse x plus cos inverse x is pi by 2, therefore sin inverse x plus cos inverse x is equal to pi by 2. Pi by 2 minus sin inverse x will be cos inverse x. And this cos inverse x now becomes equal to cos inverse 1 by 5, which implies x equals 1 by 5. This is my answer for this question. Check whether this answer is correct. This will become cos inverse 1 by 5. Sin inverse 1 by 5, the sum will be 1, sorry, the sum will be pi by 2, sin pi by 2 will be 1. Yes, this is okay, yes, it's okay, and therefore this is my answer which is correct for this equation. That's all. Let's try to solve this equation next. It is, you're given that, just a minute, this line is not used, this line is not a part of the question. You're given that if tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 is equal to pi by 4, then find the value of x. Okay, let's do it. Tan inverse of this plus tan inverse of this. How do we solve this one? Right? Without worrying about cases, you solve the question directly. Now, one of the ideas that you may have is to use tan inverse of x plus tan inverse of y. You have studied the formula of tan inverse x plus tan inverse y. You may want to use that formula directly over here. But you see, this is a complicated expression, another complicated expression. If you try to add them, you will get another complicated expression. Why not do a simpler approach? Why not follow a simpler approach and bring one tan inverse on the other side? Then apply the formula of tan inverse x minus 1 over x minus 2 plus tan inverse x plus 1 over x plus 2 is equal to pi by 4. This is given. And for solving this, instead of applying this formula directly, making the expression more complicated, what I'll do is I'll take one tan inverse on that side. What you get is tan inverse of x minus 1 over x minus 2. Let's keep that on the LHS. This is equal to pi by 4 minus tan inverse x plus 1 over x plus 2 over here. Okay. And if you want to solve this, let's take tan both sides. On taking tan, this becomes x minus 1 upon x minus 2. This is tan of pi by 4 minus tan inverse x plus 1 over x plus 2. And this is what you have. And tan of A minus B, tan of some angle minus some other angle, will be tan of this angle, which is 1, minus tan of tan inverse, which is x plus 1 over x plus 2 upon 1 plus. This is tan A minus tan B upon 1 plus tan A, which is tan pi by 4, times tan B, tan of tan inverse, which is x plus 1 over x plus 2. Keep that in mind. Right? Keep this in mind. Once you're through with this, what happens is, in the LHS you have x minus 1 and you have x minus 2, which is equal to, let's take the LCM over here, x plus 2 minus x plus 1 in the numerator, x plus 2 plus x plus 1 in the denominator. This is what you get. What happens to the x plus 2's of the denominators? They get cancelled. This simplifies to x plus 2 xx get cancelled. This is 1. This is 2x plus 3. Okay, and this is x minus 1. This is x minus 2. Now you have, you're simply supposed to cross multiply and solve for x. This is 2x plus 3, x minus 1 times 2x plus 3 is equal to x minus 2. Let's simplify this. This becomes a quadratic, right? This is 2x square plus 3x minus 2x is plus x minus 3 is equal to x minus 2. Okay, so this gives me 2x square is equal to 1. This gives me 2x square equal to 1 implies x square is equal to 1 by 2 or x will be equal to what? X square equal to 1 by 2 or x will be equal to 1 by root 2 comma minus 1 by root 2. Now which of these will be correct and which of these will be false can be checked in the original question and should be checked in the original question. Should be checked in the original question. Let's check that for x equal to 1 by root 2, what will this be? This is 1 by root 2 minus 1, this is 1 by root 2 minus 2. Okay, pretty interesting. And this is 1 by root 2 plus 1, this is 1 by root 2 plus 2 in the denominator as well. Okay, let's check that. Final answer. So this becomes 1 by root 2 minus 1, which will be actually equal to 1 minus 1 by root 2, 2 minus 1 by root 2, that's what you can write it is, by multiplying divide with minus. Okay, and what will that simplify into? Let me check that solution. Just writing a few steps would give you an idea whether the answer that you have obtained is correct or not. So tan inverse of this 1 by root 2 minus 1, or you can write 1 minus 1 by root 2, which becomes root 2 minus 1 over 2 minus x, which is 2 root 2 minus 1. This is what you get in the LHS. Now this quantity over here is positive, is again positive. What you had was negative and negative in the numerator denominator. You multiply with minus and you get this. Okay. And what you get over here is tan inverse using 1 by root 2. This becomes root 2 plus 1 upon 2 root 2 plus 1 over here. Can we add them together? Yes. This is tan inverse x plus tan inverse y. Or if you may observe, this is x times y. What is the product of x and y over here? Let's take a look at this. Root 2 minus 1 will become 1. 2 root 2 minus 1, 2 root 2 minus 1. What will that product be? This is 8 minus 1, 7. Okay, so this is 1 by 7. The product of xy is less than 1. Yes. This value is positive, this value is positive, and now I can apply the identity of tan inverse x plus tan inverse y very easily. This becomes tan inverse of this plus this over 1 minus this into this. Right? The sum of these two can be found easily by, let us say, this is 2 root 2 minus 1, this is root 2 minus 1, root 2 plus 1 over 2 root 2 plus 1. Okay, and what about the denominator? 1 minus 2, what you have is 1 minus root 2 minus 1, 2 root 2 minus 1 times root 2 plus 1 over 2 root 2 plus 1. This is what you get. Right? This is what you have. Let's take the LCM. Let's take the LCM. In the numerator, what you get is this multiplied by this multiplied by this, and in the denominator you will have 2 root 2 square minus 1 square, which is 7. Okay, so this becomes tan inverse of, as you may observe carefully, 2 root 2 times root 2 is 4, minus plus root 2, and minus 2 root 2 is minus root 2 and minus 1. This is the first term in the numerator. What about the second term in the numerator? Plus, this is 4, okay, plus 2 root 2 minus root 2 is plus root 2 and minus 1. That's what you have. What about the denominator of this numerator? This becomes 2 root 2 minus 1, 2 root 2 minus 1 plus 1, which is 7. A similar thing will happen over here as well, right? Okay, this is 7, this is 1 minus 1 by 7, which becomes 7 minus 1 upon 7. 7s in the denominators will get cancelled. What else? Root 2 and minus root 2 will get cancelled. What you get is 4 minus 1, which is 6. This is 6. This is tan inverse 6 upon 6, which is tan inverse 1, which is equal to pi by 4. So this 1 by root 2 is okay. What about that minus 1 by root 2? Now observe carefully. Observe carefully. Minus 1 by root 2 minus 1, minus 1 by root 2 minus 2. You take a minus common and this will convert into this form. Yes. 1 minus 1 by root 2 plus 1. This is 1 minus 1 by root 2. 2 minus 1 by root 2 will actually convert in this form. Okay. So both of those answers will be correct. Yes. Both the answers obtained here will be correct for this question, as you can see clearly. Right? Both answers are correct, as you can see clearly. Is that all? Yes, that's all for this question. So we have to check the answers. That's very important. Right? Even though we are solving from principal values, we have to check the answer obtained at the end, and only then we can be sure of the final answer. This is true in general for inverse trigonometric functions equations, right, based on this. And it is also true for JEE, let us say students preparing for the JEE examination. Right, that's all for this question. Let's try and solve this question next. What does the question say? Find the values of each of the expressions in exercise 16-20. Let's solve this 16. Sin inverse sin 2 pi by 3. An interesting question? Yes, an interesting question. And what's interesting about this is that the output could have been x, sin inverse sin x, the output could have been x if x lies in the interval minus pi by 2 to pi by 2, but this 2 pi by 3 does not lie in the interval. The first thing that you observe is 2 pi by 3 does not belong to the interval minus pi by 2 comma pi by 2. This is what you observe. And we remember that sin inverse sin x is equal to x only if x belongs to minus pi by 2, pi by 2. That's the range. Right. So what can we do in this one? Right. This question is relatively simple. Here you are given sin 2 pi by 3, which is a fixed value, and you can find that value first, then you can find the sin inverse of that. Yes. Or you can move in another direction. What's that? This is sin inverse sin 2 pi by 3. The angle 2 pi by 3 can be manipulated in terms of allied angles to bring that in the interval this. Right? 2 pi by 3 is actually pi minus pi by 3. Yes. So this is pi minus pi by 3. Okay. This is sin inverse sin pi by 3 actually. Pi minus theta, sin of pi minus theta is sin theta. The sin inverse sin pi by 3, which is equal to pi by 3 now, and yes, this is my answer using this. That's all. Yes, we have used a simple allied angle concept and obtained the result in this manner. That's all for this question. Let's try and solve this one. 17th, values of this expression, right? Now the first thing that we observe over here is tan inverse tan x. Tan inverse tan x will be equal to simply x when x belongs to the range of tan inverse, that is minus pi by 2 comma pi by 2. But the difficult thing that is happening over here is that 3 pi by 4 does not belong to minus pi by 2 comma pi by 2. Since it does not belong to this interval, we'll have to convert this using allied angles concept to lie in this interval. What you do is, let's begin with this. This is equal to tan inverse of tan 3 pi by 4 is actually pi minus pi by 4. Okay. And tan of pi minus theta is equal to what? This is tan inverse. Okay. Tan of pi minus theta is minus tan theta. Oh, pretty interesting. This becomes minus tan pi by 4, is it? Yes. So minus tan inverse of minus x, that is minus tan inverse x. Okay. This becomes minus tan inverse tan pi by 4. And now this tan inverse tan x is equal to x. That's my answer. Over here. That's my answer over here. You could have also written the value of tan pi by 4 as 1. This is tan inverse minus 1. The value of tan inverse minus 1 could have been found easily once again. Minus pi by 4 directly as well. That's all for this question. Let's try and simplify this question next. Find the values of each of the following expressions and exercises. Tan of sin inverse 3 by 5 plus cot inverse 3 by 5. Two complicated expressions within tan. So had this been tan inverse something and tan inverse something, things would have been very simple, right? Okay, we could have applied tan of a plus b. So let's convert this in terms of tan inverse, this in terms of tan inverse. Okay, how do we do that? Could be pretty simple, right? We can use interconversion for ITF. That is, let sin inverse 3 by 5 is equal to an angle theta, which gives me sin theta is equal to 3 by 5. What do we need? We need tan theta actually. Okay, so for from sin theta I can find cos theta is equal to 1 minus sin square theta, which is 9 upon 25 in the under root. What is that? This is 4 by 5. Sin theta is 3 by 5, cos theta is 4 by 5. Therefore, tan theta is equal to sin theta over cos theta, which is equal to 3 upon 4. That's the first thing that you observe. That's the first thing that you get over here. Okay, is that okay? Yes. Sin inverse 3 by 5 is equal to theta. For this, theta will lie in the interval in the fourth or the first quadrant. But since the value of sin theta is positive, theta lies in the first quadrant. Therefore, cos theta will also be plus 4 by 5, right? Tan theta will be plus 3 by 4. Right? Had there been any minus involved, we would have thought in other ways. But we are only looking at the first quadrant right now. What about the next? Let cot inverse 3 by 2 is equal to phi. Is equal to phi. Which gives me 3 by 2 is equal to cot phi. Okay, with the help of cot phi, I can find tan phi very easily. Tan phi is 2 by 3. Okay, and this gives me phi is also equal to tan inverse 2 by 3. Similarly here, you get that theta is also equal to tan inverse 3 by 4. Therefore, this expression over here, what will happen to this expression is equal to tan of theta plus phi. This expression is equal to tan of theta plus phi, where theta is tan inverse. Theta is tan inverse 3 by 4, phi is tan inverse 2 by 3. Or I can apply this in terms of tan theta plus tan phi over 1 minus tan theta times tan phi. Can do this? Yes, I can do this. This becomes tan theta is 3 by 4 plus tan phi is 2 by 3 over 1 minus 3 by 4 into 2 by 3. Although there is an important step which I have missed over here. What's that important step? From the point of view of NCERT, there is no issue. It will be okay. It is perfectly okay. The important step is that you can do all of this. That's not an issue. At this stage, I have to write theta plus phi first of all. That will be tan of tan inverse 3 by 4 plus tan inverse 2 by 3 in the bracket. And forget about this tan inverse 3 by 4 plus tan inverse 2 by 3 will have to be simplified by using the result tan inverse x plus tan inverse y, wherein you have to check that xy are greater than 0 and product xy is less than 1. Only then will you be able to get tan of tan inverse something. What is that something? This is something. You can see that the product xy is less than 1. Okay, and tan of tan inverse can be simplified to get this only. The product xy is less than 1. Therefore, this works, right? That's the beauty of this. This is 9 plus 8 upon 4, 3, 12. What is that? 12 minus 3 times 2, 6. Okay, what do you get is 17 over 6. That's my final answer for this question. That's the final answer for this question over here. That's all? Yes. Let's try and solve this question next. Cos inverse cos 7 pi by 6 is equal to what? Which of these options do you think will be correct over here? Cos 7 pi by 6. Let's try to simplify this. Cos inverse cos 7 pi by 6. Now this 7 pi by 6 over here is actually pi plus pi by 6, right? So this is cos inverse cos pi plus pi by 6. What will this be equal to? What will this be equal to? This is cos pi plus theta is actually minus cos theta. Yes, this is cos inverse minus cos pi by 6. Okay, so this can be simplified. Cos pi by 6 is root 3 by 2. Cos inverse minus root 3 by 2, we can move in this direction and say this is cos inverse minus square root of 3 by 2. Okay, and what will this be equal to? Cos inverse minus root 3 by 2. Can you guess the value of this? Yes, this can be very simple to guess. Minus root 3 by 2, or I can bring that minus outside. This is pi minus cos inverse root 3 by 2. Cos inverse minus x is minus cos inverse x. Yes, sorry, pi minus cos inverse x. Cos inverse minus x is pi minus cos inverse x. This is pi minus cos inverse root 3 by 2. This is pi by 6. What is that? This is 5 pi by 6. So the correct answer is option B, 5 pi by 6. Is that all? Yes, that's all. Could we have done something else as well? Yes. We could have written this as pi minus cos inverse cos pi by 6 instead of actually writing the value of this, and cos inverse cos x is equal to x if x lies in the interval 0 to pi. This pi by 6 lies in the interval 0 to pi. This is equal to this, therefore 5 pi by 6. We could have written cos inverse cos 7 pi by 6 as 7 pi by 6. No, we could not have written that because 7 pi by 6. Why are we doing this? Since 7 pi by 6 does not belong to the interval 0 comma pi. Therefore, we are supposed to work in a different manner over here. Is that all? Yes, that's all. The correct answer is this option B, as you can see behind me. Try and solve this one next. Sine of pi by 3 minus sine inverse minus 1 by 2. Okay. So let's begin with this and solve it stepwise. This is sine of pi by 3 minus sine inverse of minus 1 by 2. What happens to this minus 1 by 2? Sine inverse minus 1 by 2, I can take a minus common, this becomes a plus, this is 1 by 2. And what is sine of 1 by 2 equal to? Sine of 1 by 2, sine inverse of 1 by 2 is simply pi by 6. There is a pi by 3 already over here and you have a sine outside. Sine pi by 3 plus pi by 6 is sine pi by 2, which is 1. The value of this expression is equal to option D, that is 1. Is that all? Yes. Pi by 3 is 60, pi by 6 is 30, 60 plus 30 is 90, sine 90 degree is 1. That's all. Let's solve this question next. Tan inverse root 3 minus cot inverse minus root 3 is equal to what? How do we approach this question? Tan inverse square root of 3. Okay, we know this value. Tan inverse square root of 3. Tan inverse square root of 3 is equal to what? This is simply pi by 3. What about cot inverse minus square root of 3? So cot inverse minus square root of 3, we'll have to take care of that minus first. Okay, that minus can come out. Cot inverse minus x is pi minus cot inverse x. Root 3. And what is that? Pi minus cot inverse root 3 will be equal to pi by 6. This is 5 pi by 6. Okay. So this value is 5 pi by 6, this value is pi by 3. We're supposed to take the difference of these two. So we get pi by 3 minus 5 pi by 6 as our answer. What is that? This is 2 pi by 6 minus 5 pi by 6 is minus 3 pi by 6, which is minus pi by 2. That should be the answer of this question. Option B. That's the correct answer for this question over here. Is that all? Yes. And with this, we come to the conclusion of this exercise, the very important exercise 2.2 of inverse trigonometric functions. I hope you enjoyed watching the complete solutions of this exercise with us. If you did, then you should please like this video, share this video, and also subscribe to the channel of Vyas Edification. That is, if you haven't subscribed yet. Please subscribe to the channel of Vyas Edification so that you can get latest updates for your preparation from the point of view of all examinations that you are preparing for. All the best.